Tonight, we drift into the most profound cosmic mystery that has shaped everything you see, everything you are, and everything that will ever be. We float gently through the infinite darkness toward a secret war that began in the first moments of creation itself, a battle so fundamental, so breathtakingly beautiful, that it determines the very fabric of reality. As you settle into your comfortable space, allowing your body to sink deeper into relaxation, we prepare to journey through time and space to witness the eternal dance between matter and antimatter. This is not merely a story of particles and physics, but an epic tale of cosmic twins, locked in an ancient struggle that continues to this day. Invisible, yet omnipresent, playing out in the vast theaters of space and in the tiniest realms of quantum existence. Imagine, if you will, drifting backward through time, past the formation of our solar system, past the birth of the first stars, past the creation of the first atoms, all the way back to the very beginning, when the universe was nothing more than a point of infinite possibility. In that primordial moment, something extraordinary happened, something that would determine whether we would exist at all, whether galaxies would form, whether life would flourish, or whether everything would simply annihilate itself in a brilliant flash of pure energy. As we embark on this cosmic voyage together, let your mind become like a gentle spacecraft, floating effortlessly through the mysteries of existence. We will visit realms where normal physics breaks down, where particles pop into existence from nothingness, where mirror universes might have formed, and where the very concept of what is real becomes beautifully fluid and dreamlike. This secret war between matter and antimatter is not fought with conventional weapons, but with the fundamental forces that govern reality itself. It is a war of perfect symmetry and subtle asymmetry, of creation and annihilation, of existence and non-existence dancing together in an eternal ballet that has been choreographed by the deepest laws of nature. Tonight, as your consciousness gently relaxes and your breathing becomes slower and deeper, we will explore how this cosmic conflict gave birth to everything: the stars that light the night sky, the planets that orbit them, the elements that compose your body, and the very atoms that form your thoughts. We will discover why you exist at all, why there is something rather than nothing, and how the outcome of this ancient war continues to shape the destiny of the universe. Before we begin our journey, take a moment to appreciate the incredible fact that you are here to hear this story. Every atom in your body is a survivor of the cosmic war we are about to explore, testament to the subtle imbalance that allowed matter to triumph, just barely, over its perfect opposite. You are made of stardust that has traveled billions of years to reach this moment, carrying within it the memory of cosmic battles fought in the earliest moments of time. If you found wonder and peace in tonight's cosmic journey, consider subscribing to the Space Sleeper channel and gently pressing that like button. Your support helps us continue crafting these dreamy voyages through the mysteries of our universe, creating a community of cosmic dreamers who find beauty and rest in the infinite stories written in the stars. Now, let us begin our drift into the secret war between matter and antimatter, where we will discover that the universe itself is far stranger, far more beautiful, and far more miraculous than we ever dared to imagine. In the beginning, there was perfect symmetry, cosmic balance so exquisite, so mathematically beautiful, that it seems almost impossible such perfection could have been disrupted. Yet disrupted it was, and from that disruption emerged everything we know and love. As we drift back to those first moments of creation, imagine yourself floating in an ocean of pure potential, where the very concepts of space and time are just beginning to unfold like cosmic flowers blooming in slow motion. Picture, if you can, the universe when it was smaller than the period at the end of this sentence, containing within it all the energy that would eventually become every star, every planet, every grain of sand, and every thought that has ever existed. In this infinitesimal point, the temperature was beyond comprehension, trillions upon trillions of degrees, where energy was so concentrated that it could spontaneously transform into matter and antimatter with perfect equality, like cosmic twins being born from pure light. As we float through this primordial realm, we witness something that defies everyday understanding: the birth of particles from nothingness. Energy, in its purest form, begins to condense into matter, but nature maintains its perfect bookkeeping. For every particle of matter that springs into existence, An identical particle of antimatter appears alongside it, a perfect mirror image with opposite charge, like cosmic twins separated at birth yet forever connected by their shared origin. The first quarks emerge from the energy soup, those fundamental building blocks that will eventually combine to form protons and neutrons. But for every quark born from the primordial fire, an antiquark appears as well, identical in every way, except for its opposite electrical charge. These cosmic twins dance together in the superheated plasma, their existence precarious. Their fate intertwined with the destiny of everything that will ever be. Electrons materialize from the swirling energy field, carrying their negative charge like tiny cosmic jewels. But they are immediately joined by their antimatter counterparts, positrons, carrying positive charge with equal elegance. In these first moments, the universe maintains perfect symmetry, perfect balance, like a cosmic scale that refuses to tip in either direction. As you drift deeper into this cosmic cradle, feeling your body becoming more relaxed with each breath, imagine the incredible violence and beauty of this primordial dance. Particles and antiparticles are created in perfect pairs, their births announced by brilliant flashes of energy, their existence brief but magnificent. The early universe is a cosmic nursery where matter and antimatter twins are born by the quintillions every microsecond, each pair carrying the potential for either creation or complete annihilation. The photons, particles of light itself, sip through this cosmic soup at impossible speeds, carrying energy from one interaction to another, facilitating the endless dance of creation and destruction. These particles of light are their own antiparticles, perfect ambassadors between the warring realms of matter and antimatter, capable of transforming into either with equal ease. In this realm of perfect symmetry, we encounter one of the most profound questions in cosmology. If matter and antimatter were created in equal amounts, if the cosmic twins were born in perfect balance, why does our universe consist almost entirely of matter? What happened to antimatter's vast army? This is the central mystery of our cosmic war story, and its solution required one of the most subtle and beautiful discoveries in all of physics. As the universe expands and cools during these first fractions of a second, we can almost feel the cosmic temperature dropping, though it remains incomprehensibly hot by any earthly standard. The expansion happens so rapidly that if we could somehow observe it, it would appear as if space itself is stretching, carrying the particles and antiparticles along on a cosmic tide that never stops flowing. The strong nuclear force begins to assert itself, attempting to bind quarks together into more complex particles. But the temperature is still too extreme for stable structures to form. Instead, we witness a cosmic wrestling match where particles try to combine, while the intense heat tears them apart again and again, like cosmic lovers who cannot quite embrace in the tempestuous early universe. During this epoch, the universe is opaque to light. Photons cannot travel freely because they are constantly being absorbed and re-emitted by the dense plasma of particles. We float through a realm where light itself is imprisoned, where the cosmic twins of matter and antimatter dance in darkness, despite being surrounded by energy that outshines a trillion suns. The weak nuclear force plays its subtle role in this cosmic drama, mediating interactions between particles in ways that will prove crucial to the outcome of our cosmic war. Though it appears gentle compared to the electromagnetic and strong forces, the weak force carries within it the key to understanding why we exist at Ola. Secret that won't be revealed until much later in our journey. As we drift through these moments of perfect symmetry, we can sense the universe preparing for something momentous. The cosmic twins of matter and antimatter are about to encounter each other in numbers so vast that their mutual annihilation could have ended everything before it truly began. The stage is set for the most important battle in the history of existence, a battle whose outcome would determine whether the universe would remain forever empty or become the rich, complex, beautiful cosmos we inhabit today. Imagine yourself floating peacefully through this realm of cosmic potential, where every quantum fluctuation carries within it the seeds of galaxies yet to be born, where every particle and particle pair represents a moment of perfect symmetry in a universe that is about to become beautifully asymmetric. The cosmic twins have been born, and their destiny and ours hangs in the perfect balance of those first moments of creation. The electromagnetic field permeates everything, creating invisible connections between particles separated by vast distances. like cosmic spiderwebs that will eventually help organize matter into the structures we observe today. These fields carry information at the speed of light, ensuring that the cosmic twins remain aware of each other's presence. Even as the universe expands around them, as the first second of the universe's existence approaches its end, we prepare to witness the great encounter at the moment when the cosmic twins of matter and antimatter will meet in vast numbers, their collision destined to reshape the very nature of reality. The perfect symmetry of creation is about to give way to the beautiful imperfection that makes existence possible. In this cosmic nursery where the twins were born, we find ourselves at the threshold of understanding one of the deepest mysteries in science. Why is there something rather than nothing? Why do we exist to contemplate our own existence? The answers lie ahead in our journey as we prepare to witness the cosmic war that saved the universe from perfect empty symmetry and gave it the gorgeous complexity. It allows stars to shine, planets to form, and consciousness to emerge from cosmic dust. As we conclude this first chapter of our cosmic story, let your mind rest gently on the image of perfect twins being born from pure energy. Their dance of creation and potential annihilation playing out against the expanding canvas of space-time itself. The universe has prepared the stage, the cosmic actors have appeared, and the greatest drama in the history of existence is about to unfold. Take a deep, slow breath and allow your mind to float peacefully through the cosmic nursery we have just explored. Feel your body sinking deeper into relaxation as you contemplate the perfect symmetry of those first moments when matter and antimatter dance together in perfect balance. Unaware of the magnificent asymmetry that would soon give birth to everything we know and love. As we continue our gentle drift through the cosmos of possibility, let us imagine what might have been a universe where antimatter claimed victory in the cosmic war, where the mirror twins of our familiar particles became the dominant force shaping reality. This is the universe that never was, a perfect reflection of our own cosmos, where everything we know exists in reverse, like looking into a cosmic mirror that shows us the road not traveled. Picture yourself floating through this alternate reality, where anti-hydrogen atoms form the building blocks of anti-stars, their nuclei composed of antiprotons, embracing positrons in orbital dances that mirror our own atomic structures with perfect precision. These anti-atoms behave identically to their matter counterparts, following the same physical laws, obeying the same mathematical principles, yet carrying within them the fundamental reversal that makes them the perfect opposite of everything familiar. In this mirror universe, vast clouds of antimatter gas drift through space like cosmic ghosts of our own nebulae.
Ow.
These antinebulae glow with the same ethereal beauty as their matter counterparts, their anti-hydrogen and anti-helium atoms excited by the light of nearby anti-stars, creating spectacular displays that would be indistinguishable from the northern lights of our own world, except for the fundamental reversal at their quantum heart. As you drift deeper into this realm of cosmic reflection, imagine anti-stars burning in the darkness, massive spheres of antimatter, undergoing the same nuclear fusion processes that power our sun, but with antiprotons combining to form heavier anti-elements in their cores. These stellar furnaces shine with identical brightness and warmth, their light composed of the same photons that illuminate our universe. 4 photons are their own antiparticles, serving as perfect ambassadors between the realms of matter and antimatter. The anti-galaxies spiral through space with the same elegant patterns as our Milky Way, their spiral arms traced by the light of billions of anti-stars, their centers harboring supermassive anti-black holes that bend space-time in identical ways to their matter cousins. Dark antimatter provides the invisible scaffolding upon which these cosmic structures are built, creating the same beautiful web of filaments and voids that characterizes our observable universe. In this mirror cosmos, anti-planets orbit their anti-stars in the same graceful ellipses that govern our solar system. An anti-Earth might exist, its surface composed of familiar anti-elements arranged in reverse antisilicon and antioxygen forming antiquartz crystals, anti-carbon and anti-hydrogen creating anti-organic compounds that could theoretically support anti-life in all its potential complexity and beauty. Imagine anti-oceans lapping against anti-shores, their anti-water molecules identical in behavior to our familiar H2O, yet composed of positrons orbiting anti-oxygen nuclei in perfect mimicry of terrestrial chemistry. Anti-weather patterns would swirl through anti-atmospheres, driven by the same thermodynamic principles that create our clouds and storms, yet fundamentally reversed at the most basic level of reality. As we float through this hypothetical anti-biosphere, we might encounter anti-life itself, organisms built from anti-carbon chains. They're anti-DNA, carrying genetic information encoded in the same 4 anti-bases that could theoretically store the blueprints for anti-evolution. These anti-creatures would metabolize anti-sugars, breathe anti-oxygen, and think anti-thoughts that mirror our own cognitive processes while remaining fundamentally opposite in their quantum essence. The beauty of this mirror universe lies not in its strangeness, but in its familiar unfamiliarity. Anti-consciousness might contemplate anti-existence, wondering about the nature of anti-reality while gazing up at anti-stars that spell out the same constellations in reverse. Anti-scientists might discover anti-physics, formulating equations that describe the behavior of antimatter with the same elegant mathematics we use to understand our matter-based cosmos. In this realm of perfect reversal, anti-time flows in the same direction as our time. Contrary to popular misconceptions, antimatter does not reverse temporal flow. Anti-entropy increases just as relentlessly as entropy in our universe, and anti-energy follows the same conservation laws that govern our reality. The mirror universe is not a place where effects precede causes or where anticlocks tick backward, but rather a place where the fundamental building blocks carry opposite charges while obeying identical physical principles. As your mind drifts peacefully through this cosmic thought experiment, consider the profound symmetries that govern existence. In our imagined anti-universe, anti-love might exist not as hatred, but as genuine affection between anti-beings. They're anti-neurotransmitters creating the same emotional experiences we cherish, yet built from particles that would annihilate with our own upon contact. Anti-beauty would inspire anti-W, and anti-consciousness would contemplate anti-meaning with the same depth and wonder that characterizes our own philosophical inquiries. The tragic beauty of this mirror universe is that it could have been our reality. The first moments after the Big Bang, when matter and antimatter existed in nearly perfect balance, the cosmic coin flip could have landed on the opposite side. Antimatter could have gained the slight advantage that matter ultimately claimed, and we might have been anti-beings wondering about the nature of the matter universe that never was. In our hypothetical anti-cosmos, anti-artists might create anti-masterpieces that capture the same aesthetic truths we find in our art. They're anti-pigments reflecting anti-photons to create visual experiences that parallel our own appreciation of beauty. Anti-musicians might compose anti-symphonies that resonate with anti-emotions imprecisely, the same way our music touches the deepest parts of our matter-based souls. The mirror universe would age and evolve according to the same cosmic schedule as our own. Anti-stars would be born from collapsing anti-gas clouds, live their lives burning anti-fuel in their cores, and eventually die. And anti-supernovas that scatter anti-elements throughout anti-space, seeding future generations of anti-stars and anti-planets with the heavy anti-elements necessary for anti-complexity and anti-life. As we drift through the cosmic graveyards of this alternate reality, we might encounter anti-neutron stars, incredibly dense spheres of anti-neutrons that pulse with anti-radiation as they spin, creating anti-lighthouses that sweep beams of anti-RG across the anti-cosmos. These anti-pulsars would keep perfect time, their anti-atomic clocks synchronized with the fundamental constants that govern both universes equally. The most haunting aspect of our mirror universe is its perfect isolation from our own cosmos. Should matter and antimatter universes somehow encounter each other, they would not coexist or merge. They would annihilate in the most spectacular release of energy imaginable, converting both realities into pure radiation that carries no memory of the complex structures. The anti-life, the anti-consciousness, or the anti-dreams that once existed. In our anti-cosmos, anti-black holes would warp anti-spacetime in identical ways to their matter counterparts, creating the same gravitational lensing effects that allow us to peer deeper into space and time. Anti-Hawking radiation would slowly evaporate these cosmic monsters over the same impossibly long timescales, ensuring that even in the mirror universe, entropy marches inexorably toward heat death and perfect equilibrium. Well, as we prepare to leave this realm of cosmic reflection, let your mind rest on the profound realization that the universe that never was might have been just as beautiful. just as complex, and just as capable of supporting consciousness and meaning as our own reality. The mirror universe represents not just a scientific curiosity, but a meditation on the nature of existence itself, reminder that the cosmos we inhabit is both inevitable in its physical laws and miraculous in its specific configuration. The anti-children of this hypothetical cosmos might have fallen asleep to anti-bedtime stories about matter universes that never existed. Their anti-parents weaving tales of strange particles with familiar properties, but opposite charges. Anti-dreamers might have dreamed anti-dreams of floating through matter-filled space, wondering what it would be like to be made of the opposite kind of substance, while remaining fundamentally, beautifully conscious. In the end, the mirror universe that never was serves as a perfect philosophical mirror for our own existence. It reminds us that our matter-based reality is not the only possible configuration of the cosmos, but rather one branch of an infinite tree of possibility, a branch that happened to grow while its perfect twin remained. Forever in the realm of potential, beautiful and complete in its non-existence, yet no less real in its mathematical perfection. As we drift forward through cosmic time from the realm of perfect possibility, we approach one of the most dramatic and consequential moments in the history of existence, the Great Annihilation. When the cosmic twins of matter and antimatter met in numbers so vast that their mutual destruction released energy beyond imagination, nearly ending the universe before it had truly begun. Let your consciousness float gently toward this cosmic catastrophe, this beautiful apocalypse that paradoxically saved reality from perfect emptiness. Picture the universe when it was approximately 1 second old, still unimaginably hot and dense, yet cool enough for the first stable particles to maintain their existence for more than fleeting moments. The temperature has dropped to a mere 10 billion degrees, and in this relative coolness, protons and neutrons begin to form from the quark-gluon plasma that has filled space since the beginning. But for every proton that emerges from the cosmic furnace, an antiproton materializes as well, and for every neutron, an antineutron appears like a shadow cast in reverse. As you float through this primordial realm, imagine the cosmic stage being set for the most spectacular light show in history. Trillions upon trillions of particles and antiparticles swirl through space in a dense soup of potential energy, their paths destined to intersect in collisions that will determine the fate of everything. The universe holds its breath, balanced on the knife's edge between existence and oblivion, between the rich complexity we know and the perfect symmetry of nothingness. The first encounters between matter and antimatter begin as the universe continues to expand and cool. When a proton meets an antiproton, they do and simply bounce off each other like cosmic billiard balls. They embrace in a dance of mutual destruction so complete that both particles cease to exist entirely. Their combined mass converted into pure energy according to Einstein's most famous equation. The energy released from a single such encounter could power a small city for microseconds. And these encounters are happening by the quintillions every instant. Watch as electrons and positrons find each other across the cosmic battlefield, their opposite charges drawing them together like star-crossed lovers in a cosmic tragedy. When they meet, they too vanish in a brilliant flash of annihilation radiation, their entire existence transformed into high-energy photons that carry away the memory of their brief, packed in packets of pure light. These gamma rays, the most energetic form of electromagnetic radiation, become the cosmic messengers that tell the story of universal destruction. The Great Annihilation is not a single moment, but a cosmic epoch, lasting several seconds, an eternity in the fast-paced timeline of the early universe. During this period, the cosmos becomes a vast arena where matter and antimatter wage their final battle, each side seemingly matched in numbers, each particle finding its perfect opposite in a choreography of mutual destruction that fills space with the most intense radiation ever produced. As we drift through this cosmic furnace, we can almost feel the temperature fluctuations as massive amounts of matter and antimatter convert to pure energy, only to have that energy immediately create new particle and type particle pairs in an endless cycle of creation and destruction. The universe becomes a cosmic recycling plant, where mass becomes energy, becomes mass again, over and over, in a dance that seems like it could continue forever. But something subtle is happening in this apparent symmetry, something so small it seems insignificant. yet so profound it will determine whether anything exists at all. For every billion particle and type particle pairs that annihilate into pure energy, one tiny matter particle survives without finding its antimatter twin. This imbalance is so slight, 1 part in a billion, that it would be easy to overlook if not for its cosmic significance. Imagine yourself floating through space that is filled with the most intense light ever produced, as the annihilation radiation from countless particle collisions creates a cosmic flash that outshines anything we can observe in today's universe. This is the universe's great death cry and birth scream, combined into one moment when perfect symmetry dies and beautiful asymmetry is born from its ashes. The photons created by each annihilation event carry tremendous energy, hot enough to immediately create new particle and type particle pairs from the vacuum itself. But as the universe continues to expand, the average energy of these photons decreases due to cosmic redshift, and eventually they lack sufficient energy to create the heaviest particles. The era of easy particle creation begins to end, but the era of annihilation continues as existing particles find their antimatter partners. During this cosmic holocaust, entire categories of particles face extinction. The heavy particles, the muons and pions and strange particles created in the universe, its first moments find their antimatter twins and vanish in brilliant flashes of energy. Only the lightest and most stable particles have any hope of surviving the great cosmic purge that is eliminating nearly everything that exists. As we witness this cosmic clearing, we observe something remarkable. The universe is simplifying itself. The bewildering zoo of exotic particles that filled the early cosmos is being reduced to just a few fundamental survivors. Protons, neutrons, electrons, neutrinos, and photons become the primary actors in the cosmic drama. Their antimatter counterparts, mostly eliminated in the great mutual destruction. The neutrinos, ghostly particles that barely interact with anything, manage to escape the carnage more easily than their charged cousins. They drift through the cosmic battlefield like invisible spirits, occasionally annihilating with their antimatter twins, but mostly surviving due to their extremely elusive nature. These relic neutrinos still fill the universe today, carrying within them the memory of this ancient cosmic war. As the great annihilation reaches its climax, we can observe the universe transforming from a complex particle democracy into a simpler cosmic aristocracy. The surviving particles are the hardy survivors, cosmic cockroaches that manage to outlast the greatest catastrophe in history. But even among these survivors, the balance between matter and antimatter continues to shift in favor of matter by that crucial 1 part in a billion margin. The energy released during this epoch is so enormous that it drives the cosmic expansion faster than it might otherwise have proceeded. The universe inflates like a cosmic balloon, being filled with the energy of its own self-destruction, space itself stretching to accommodate the incredible radiation pressure generated by countless annihilation events occurring every nanosecond throughout the observable cosmos. As we float through the aftermath of peak annihilation, we observe the universe beginning to change character fundamentally. Where once there were nearly equal numbers of particles and antiparticles, now there is mostly radiation with a tiny seasoning of matter particles. The survivors of the Great Massacre, the remnant that will eventually become galaxies, stars, planets, and conscious beings capable of contemplating their own existence. The cosmic microwave background radiation that we can still detect today is the cooled down echo of this great annihilation, the faint afterglow of the moment. When the universe nearly destroyed itself through perfect symmetry, every time we tune a radio to static, a small fraction of that noise comes from the relic radiation of matter-antimatter annihilation that occurred when the universe was less than a minute old. The beauty of the great annihilation lies not in its destruction, but in its imperfection. If the universe had been perfectly symmetric, if matter and antimatter had been created in exactly equal amounts, the great annihilation would have been complete. Every particle would have found its perfect opposite. Everything would have been converted to radiation, and the universe would have evolved into a sea of cooling photons with no structure, no complexity, no life, and no consciousness. Instead, the tiny asymmetry, that 1 part in a billion imbalance that favored matter over antimatter, saved the universe from perfect emptiness. This subtle bias ensured that when the cosmic smoke cleared and the annihilation energy cooled, there would still be raw material left to build the rich, complex, beautiful cosmos we inhabit today. As we conclude our journey through the great annihilation, let your mind rest on the profound realization that you are made from the survivors of this cosmic war. Every atom in your body is descended from particles that won the ultimate lottery. They were among the 1 in a billion matter particles that failed to find an antimatter twin and thus survived to tell the tale. We're not just made of star dust. You are made of the cosmic survivors who outlasted the universe's attempt to destroy itself through perfect symmetry. The great annihilation represents both the closest the universe ever came to non-existence and the moment when existence became inevitable. From this cosmic near-death experience emerged the possibility of everything: chemistry, biology, consciousness, love, art, music, dreams, and the very thoughts you are thinking as you drift peacefully through this cosmic story, carried gently towards sleep by the lullaby of ancient light that still whispers the tale of creation's most dramatic moment. Let your breathing become slow and deep as you contemplate the cosmic survivors that compose your very being. Feel your body relaxing completely as you realize that every atom within you carries the memory of that ancient victory, when matter barely triumphed over antimatter and saved the universe from perfect empty symmetry. As we drift deeper into the cosmic mystery, floating gently through the aftermath of the great annihilation, we approach one of the most profound questions in all of science. Why did matter win the cosmic war? What caused the tiny but crucial imbalance that saved the universe from perfect sterile symmetry? This mystery has captivated the greatest minds in physics, leading them on a quest to understand the deepest principles governing reality itself. Let your consciousness float peacefully through this realm of cosmic detective work, where scientists have spent decades searching for clues hidden in the behavior of the most fundamental particles. The mystery begins with a simple observation that carries profound implications. If the Big Bang created matter and antimatter in perfect equality, as our understanding of physics suggests it should have, then the great annihilation should have been complete, leaving behind only radiation and empty space. But here we are, you and I, composed of matter, existing in a universe filled with matter-based stars and planets and galaxies, contemplating our own existence in defiance of what perfect symmetry would predict. We are living evidence that somewhere, somehow, the cosmic balance was tipped ever so slightly in favor of matter, allowing the survivors of the great annihilation build the complex structures we observe today. The answer to this cosmic mystery lies in one of the most subtle and beautiful concepts in physics, CP violation, where CP stands for charge conjugation and parity, two fundamental symmetries that govern how particles behave. Imagine these symmetries as cosmic mirrors that should reflect matter and antimatter with perfect fidelity, but occasionally produce reflections that are slightly distorted, creating the tiny asymmetries that save the universe from emptiness. As we float through the realm of particle physics, we encounter the chaos and strange, ephemeral particles that live for only tiny fractions of a second, but carry within their brief existences the secret of cosmic survival. In the 1960s, scientists discovered that when these particles decay, they violate the expected symmetries in ways so subtle that the effect was almost missed entirely. These tiny violations became the first clues in solving the mystery of matter's triumph. Picture yourself drifting through a cosmic laboratory where the fundamental forces of nature reveal their deepest secrets. The weak nuclear force, that gentle giant among the cosmic forces, turns out to be the key player in creating the antimatter asymmetry. Unlike the electromagnetic and strong forces, which treat matter and antimatter with perfect equality, the weak force has a subtle bias, cosmic preference that slightly favors the creation of matter over antimatter. This bias manifests through processes so rare and fleeting that they occur only once in billions of interactions. But in the early universe, when particle interactions were happening at rates beyond imagination, these rare events accumulated into the cosmic asymmetry that saved everything. The weak force, despite its name, wielded the power to determine the fate of existence itself through its subtle symmetry violations. As we explore deeper into this mystery, we encounter the Higgs field, that invisible ocean of energy that fills all of space and gives particles their mass. Recent discoveries suggest that the Higgs field may have played a crucial role in creating the matter-antimatter asymmetry during the universe's earliest moments, when temperatures were so extreme that the very nature of space and matter was fundamentally different from what we observe today. Imagine floating through the cosmic phase transitions that occurred as the universe cooled, moments when the fundamental forces separated from their primordial unity, like cosmic rivers diverging from a single source. During these transitions, the asymmetries that would determine matter's victory may have been frozen into the fabric of reality itself, ensuring that when the Great Annihilation occurred, matter would retain its crucial 1 in a billion advantage. The mystery deepens when we consider that the precise amount of asymmetry appears to be perfectly tuned for the existence of complex structures. Too little asymmetry, and the universe would have been nearly empty after annihilation, lacking sufficient matter to form galaxies and stars. Too much asymmetry, and the annihilation process would have been incomplete, leaving the universe too dense and hot for stable structures to form. As your mind drifts peacefully through these cosmic coincidences, consider the remarkable fact that the amount of matter surviving the Great Annihilation was exactly what was needed to create a universe capable of supporting complexity, structure, and eventually consciousness. This fine-tuning seems almost miraculous, a cosmic Goldilocks effect where everything had to be just right. For existence as we know it to be possible, scientists have proposed various mechanisms to explain how this perfect asymmetry arose. One beautiful possibility involves a hypothetical epoch called baryogenesis, when the universe was so young and hot that the normal rules of particle physics were suspended, allowing processes that could create more matter than antimatter to occur naturally. During this cosmic alchemy, the fundamental symmetries of nature may have been temporarily broken, creating the seeds of asymmetry that would later save the universe. Another intriguing possibility involves the existence of additional spatial dimensions beyond the 3 we experience daily. In these higher dimensional theories, our universe might be like a cosmic membrane floating in a higher dimensional space, and the matter-antimatter asymmetry could have arisen from interactions between our membrane universe and others, creating the imbalance through processes that remain largely theoretical but mathematically elegant. The neutrinos, those ghostly particles that barely interact with ordinary matter, may also hold keys to understanding cosmic survival. Some theories suggest that neutrinos might be their own antiparticles, and if so, their behavior in the early universe could have contributed to creating the matter-antimatter asymmetry through processes involving the violation of lepton number conservation. As we float through these theoretical landscapes, we encounter the concept of cosmic inflation, a period of exponential expansion that may have occurred in the universe's first tiny fraction of a second. During inflation, quantum fluctuations could have been stretched to cosmic scales, and some theories suggest that the matter-antimatter asymmetry could have been generated during this inflationary epoch, seeded by quantum mechanical processes. Operating at the smallest possible scales, the mystery of survival becomes even more profound when we consider that multiple independent mechanisms may have contributed to matter's victory. The universe may have employed a cosmic redundancy system, using several different physical processes to ensure that the crucial asymmetry would be generated regardless of which specific mechanism dominated. Now, during the earliest moments of existence, recent discoveries in particle physics continue to illuminate aspects of this cosmic mystery. The discovery of new forms of CP violation in different particle systems suggests that the universe may have had multiple pathways to generate the matter-antimatter asymmetry, like a cosmic safety net, ensuring that existence would survive regardless of which particular mechanism operated most effectively. As we contemplate the beauty of these survival mechanisms, we realize that the mystery of matter's triumph represents one of the deepest connections between the smallest scales of reality and the largest structures in the cosmos. The same quantum mechanical processes that govern individual particle interactions also determine the fate of galaxies. Stars, and ultimately conscious beings, capable of pondering their own existence. The survival of matter over antimatter also connects intimately with the concept of cosmic time's arrow, the fundamental asymmetry that distinguishes past from future. The same underlying physics that created the matter-antimatter imbalance may also be responsible for the thermodynamic arrow of time that allows complexity to emerge from simplicity and consciousness to arise from cosmic dust as we drift toward the conclusion of this chapter on cosmic survival. Let your mind rest on the incredible improbability and perfect necessity of your own existence. You are composed of matter that survived the universe's greatest catastrophe through mechanisms so subtle and beautiful that scientists are still working to understand them completely. Every atom in your body carries within it the memory of cosmic processes that operated when the universe was younger than a heartbeat. The mystery of survival reminds us that existence itself is both incredibly fragile and remarkably robust. It required the most delicate fine-tuning of fundamental physical processes to create the conditions for matter's survival. Yet once that survival was ensured, the universe proceeded to create the rich tapestry of structure and complexity that surrounds us today. As you continue your drift toward peaceful sleep, carried by the cosmic currents of this ancient story, remember that you are not just an observer of these cosmic mysteries, you are their direct consequence. Your consciousness, your dreams, your capacity for wonder and love, all exist because of the subtle asymmetries that allowed matter to triumph over antimatter in the first moments of creation. You are the universe's way of contemplating its own miraculous survival, the cosmos dreaming about itself through the medium of awakened matter. As we continue our gentle drift through the cosmic story, floating now through the present-day universe where matter has claimed apparent victory, we discover that antimatter has not entirely disappeared from the cosmic stage. Instead, it has retreated to hidden realms and secret sanctuaries, continuing to play its mysterious role in the ongoing dance of existence. Let your consciousness float peacefully toward these invisible kingdoms where antimatter still reigns, still creates, and still maintains its ancient cosmic significance. High above the protective embrace of our atmosphere, of space where cosmic rays traverse impossible distances, antimatter continues to be born from the violent interactions between high-energy particles and the fabric of space-time itself. Picture yourself floating in the emptiness between stars, witnessing the cosmic particle accelerators that dwarf anything humans have ever constructed: supernova remnants, neutron star magnetospheres, and the accretion disks around black holes, all serving as natural factories for antimatter production. When cosmic ray protons, particles accelerated to nearly the speed of light by cosmic catastrophes, collide with atoms in interstellar space or planetary atmospheres, they create brief, brilliant showers of secondary particles that include antimatter twins. Positrons spark into existence like cosmic fireflies, living brief but brilliant lives before finding electrons to annihilate with. Their deaths marked by characteristic gamma-ray flashes that tell the story of matter-antimatter encounters still occurring throughout the universe. These cosmic ray interactions create a constant, gentle rain of antimatter falling upon our planet. Positrons and antiprotons arriving as messengers from distant cosmic violence, their journey across the galaxy serving as proof that the ancient war between matter and antimatter continues in subtle ways throughout the modern universe. Most of these antimatter visitors annihilate almost immediately upon entering our matter-dominated environment, but their brief presence connects us to the ongoing cosmic drama as we drift deeper into antimatter's hidden realms. We encounter one of nature's most elegant solutions to the antimatter shortage: radioactive decay processes that spontaneously create positrons within the hearts of matter itself. Certain unstable atomic nuclei, seeking stability through beta-plus decay, transform protons into neutrons, while birthing positrons that emerge like antimatter phoenixes from the atomic furnaces within ordinary matter. These naturally occurring antimatter sources exist all around us, hidden within the potassium in bananas, the carbon in our bodies, and the fluorine in our teeth. Every few minutes, your body produces positrons through natural radioactive processes, tiny sparks of antimatter that immediately encounter electrons and vanish in gentle flashes of annihilation radiation, so mild they pose no danger. That's so profound, they represent the ongoing creation and destruction that characterizes existence at its most fundamental level. Picture yourself floating through the vast magnetospheres of planets, where charged particles from the solar wind become trapped in invisible magnetic bottles, creating radiation belts that serve as natural antimatter reservoirs. Earth's Van Allen belts contain substantial quantities of energetic positrons, cosmic antimatter captured and contained by our planet's magnetic field, creating a hidden antimatter halo that surrounds us at all times. Jupiter's massive magnetosphere serves as the solar system's greatest natural antimatter factory, its powerful magnetic field trapping and accelerating particles to such extreme energies that antimatter production becomes routine. The giant planet's radiation environment creates positrons in such abundance that spacecraft visiting the Jovian system must be specially shielded against the antimatter radiation that bathes the entire region around the gas giant. As we explore the hidden antimatter realms of our own solar system, we discover that the Sun itself is a prolific antimatter producer. Within the solar core, where hydrogen nuclei fuse to create helium, every fusion reaction produces neutrinos and positrons as byproducts. These solar positrons typically annihilate with electrons almost immediately, but their creation represents a continuous antimatter fountain operating at the heart of our life-giving star. The most exotic antimatter reservoirs may exist near the event horizons of black holes, where the intense gravitational fields create conditions so extreme that particle and pairs can be spontaneously created from the vacuum itself, through a process called Hawking radiation. Black holes may slowly evaporate by creating matter-antimatter pairs at their event horizons, with one particle falling into the black hole while its partner escapes, carrying away the black hole's mass and energy in the form of radiation that includes antimatter components in the accretion disks surrounding black holes and neutron stars. Matter falling toward these cosmic monsters reaches temperatures of millions of degrees and velocities approaching the speed of light. These extreme environments serve as natural particle accelerators where antimatter production occurs routinely, creating jets of high-energy particles that may contain substantial antimatter components streaming away from these cosmic engines. At relativistic speeds, gamma bursts the most energetic explosions in the universe after the Big Bang. Itself may create antimatter in such quantities that entire antimatter clouds could exist temporarily in their aftermath. These cosmic cataclysms, possibly caused by colliding neutron stars or black holes, release more energy in a few seconds than our Sun will produce in its entire 10 billion-year lifetime, creating conditions extreme enough to manufacture antimatter. On astronomical scales, as we float through the interstellar medium, we discover that space itself may contain more antimatter than previously thought. Recent observations have detected mysterious signals that could indicate the presence of primordial antimatter, ancient remnants of the Big Bang that somehow avoided annihilation and survived in isolated pockets of space, possibly in the form of anti-atoms or even larger antimatter structures. The center of our galaxy presents one of the most intriguing antimatter mysteries in astronomy. Observations have revealed a fountain of positrons emanating from the galactic center, creating an antimatter glow that extends for thousands of light-years around the supermassive black hole at the Milky Way's heart. The source of these positrons remains unknown. They could be produced by black hole activity, dark matter interactions, or even from a population of pulsars we haven't yet discovered in the vast cosmic web that connects galaxies across the universe. Tenuous filaments of hot gas may harbor antimatter created by cosmic ray interactions over billions of years. These intergalactic highways, invisible to the naked eye but detectable through their effects on light passing through them, could serve as reservoirs where antimatter accumulates slowly over cosmic time, creating hidden antimatter streams flowing between the galaxies. As we explore antimatter's role in modern astrophysics, we discover that it may be crucial for understanding some of the universe's most energetic phenomena. The jets of material ejected by quasar supermassive black holes actively feeding on surrounding matter may contain significant antimatter components that help explain their incredible luminosity and their ability to remain collimated over distances of millions of light years. Perhaps the most profound hidden realm of antimatter exists within the quantum vacuum itself, the supposedly empty space that fills the universe. According to quantum field theory, this vacuum is actually a seething ocean of particle-antiparticle pairs. It's constantly appearing and annihilating in timescales so brief that they cannot be directly observed. Yet their cumulative effects can be measured and have been confirmed by experiments. These virtual particle pairs, including virtual matter and antimatter, influence the behavior of real particles and fields throughout the universe. They contribute to the Casimir effect, modify the magnetic properties of electrons, and may even play a role in the mysterious dark energy that appears to be accelerating the universe's expansion. In this sense, antimatter maintains a ghostly but measurable presence throughout all of space and time. The hidden realms of antimatter remind us that the cosmic war between matter and antimatter never truly ended. It simply moved to more subtle battlefields where the ancient opponents continue their eternal dance. Every cosmic ray interaction, every radioactive decay, every black hole evaporation represents a continuation of the primordial conflict that shaped the early universe. It continues to influence cosmic evolution today. As we conclude our exploration of antimatter's hidden realms, let your mind drift peacefully through the realization that you exist within a universe still permeated by the products and processes of the ancient matter-antimatter war. The very atoms of your body occasionally produce antimatter through radioactive decay, connecting you directly to these cosmic processes, making you a temporary host to the ongoing creation and annihilation that characterizes existence at its deepest level. Even as you rest, cosmic rays are creating antimatter in the atmosphere above you. Radioactive elements in the earth beneath you are producing positrons. The quantum vacuum around you seethes with virtual particle pairs appearing and disappearing in the cosmic dance that has continued unabated since the first moment of creation. You are not separate from these processes. You are immersed in them, part of them, conscious expression of the universe's ongoing exploration of the balance between existence and non-existence, between matter and its perfect opposite. Feel your breathing slow and deepen as you contemplate the invisible antimatter processes occurring all around you in the air, in your body, in the quantum vacuum itself. Let this awareness of the ongoing cosmic dance gently guide you toward deeper relaxation, knowing that you are part of a universe still actively exploring the mysteries of matter and antimatter. As we drift forward through cosmic time from the hidden realms where antimatter survives in nature, we approach one of humanity's greatest achievements in the quest to understand the cosmic war: the construction of earthbound laboratories where we have learned to create and control antimatter itself. These temples of science represent our species' boldest attempt to recreate the conditions that existed in the first moments after the Big Bang, to manufacture the cosmic twins that shaped the early universe, and to probe the deepest mysteries of existence through direct experimentation. Picture yourself floating gently through the corridors of CERN, the European Organization for Nuclear Research, where the world's most powerful particle accelerators hum with energies that rival those present in the cosmic aftermath of creation itself. Here, in underground tunnels stretching for miles beneath the Swiss-French border, scientists have built machines that serve as time machines, recreating conditions that last existed when the universe was less than a second old. The Large Hadron Collider, that magnificent ring of superconducting magnets and detection equipment, codelettes, operates at temperatures colder than the cosmic microwave background radiation that fills space colder than anywhere else in the known universe, while simultaneously creating collisions hotter and more energetic than the center of the sun. In these controlled cosmic catastrophes, matter and antimatter spring into existence, just as they did in the primordial universe. allowing us to witness firsthand the birth of cosmic twins. As we float through the moment of collision, when proton beams traveling at 99.9999% the speed of light meet head-on, we witness a miniature recreation of the Big Bang itself. The protons, carrying the kinetic energy equivalent to freight trains compressed into spaces smaller than atomic nuclei, transform their motion into matter and antimatter through Einstein's mass energy equivalence, creating showers of particles and antiparticles that mirror the cosmic particle zoo that filled the early universe. In these microscopic explosions, lasting less than a trillionth of a second, antiprotons, positrons, and more exotic antimatter particles materialize. From pure energy, just as they did during the Great Annihilation, advanced detector systems, themselves marvels of engineering containing millions of sensors and processing systems, track these ephemeral antimatter particles through their brief existence, measuring their properties and behaviors with precision that would have seemed magical to earlier generations of scientists. The creation of antimatter in these cosmic laboratories requires energy so immense that the entire process operates at an efficiency that makes antimatter the most expensive substance ever produced by human civilization. To create a single antiproton requires about 1 billion times more energy than the antiproton contains in its mass, making antimatter production a cosmic alchemy that transforms vast amounts of electrical energy into tiny quantities of the universe's most exotic matter. As we drift through the detector caverns where these cosmic recreations are observed, we encounter cathedral-like spaces filled with experimental apparatus that represents the pinnacle of human technological achievement. The Atlas and CMS detectors, each weighing as much as a Navy destroyer and containing electronics more complex than anything else ever built, serve as cosmic cameras capable of photographing the birth and death of antimatter with temporal and spatial resolution beyond imagination. The process of antimatter storage presents challenges that push the boundaries of human, since antimatter annihilates instantly upon contact with ordinary matter. It must be contained without touching any material substance, a seemingly impossible task that scientists have solved through the use of electromagnetic and magnetic traps that suspend individual antimatter particles in perfect vacuum chambers, creating tiny prisons of light that hold the cosmic twins in isolation. Picture the Antimatter decelerator at CERN, a machine specifically designed to capture the antimatter particles created in high-energy collisions and slow them down to speeds where they can be studied in detail. This cosmic fishing net uses magnetic fields and electric fields to catch antiprotons traveling at significant fractions of light speed and gradually reduce their velocity until they can be trapped and stored for extended periods, sometimes for months at a time. The creation of antiatoms represents one of the most profound achievements in these laboratories of creation. Scientists have successfully combined antiprotons and positrons to create antihydrogen atoms, the antimatter mirror of the most common atom in the universe. These antiatoms, consisting of a positron orbiting an antiproton, represent the first artificial antimatter structures complex enough to have chemical properties, opening the possibility of antimatter chemistry and antimatter spectroscopy. As we float through the alpha experiment, we witness the delicate ballet required to create and study these antiatoms. Magnetic traps with field strengths thousands of times stronger than Earth's magnetic field create invisible bottles that can hold a few hundred antihydrogen atoms at temperatures just above absolute zero, allowing scientists to probe their properties with laser light and compare them to ordinary hydrogen atoms with unprecedented precision. The study of antimatter in these cosmic laboratories has revealed one of the most important confirmations of fundamental physics. Antimatter behaves exactly as theory predicts in terms of its particle properties. Yet the universe clearly treated matter and antimatter asymmetrically in its earliest moments. This apparent contradiction drives much of the current research in particle physics and cosmology, as scientists seek to understand why the cosmic twins were not truly identical in their cosmic fate. The gravitational behavior of antimatter represents One of the most profound questions being explored in these laboratories: does antimatter fall upward or downward in Earth's gravitational field? Theory strongly suggests it should fall downward, just like ordinary matter. But experimental verification of this prediction requires incredible precision and represents one of the holy grails of antimatter research. The AlphaG experiment is designed to measure the gravitational acceleration of antihydrogen atoms with sufficient accuracy to test Einstein's equivalence principle for antimatter. As we explore the technological marvels that make antimatter research possible, we encounter systems that operate at the very limits of what physics allows. Superconducting magnets cooled to within degrees of absolute zero create magnetic fields, precise enough to trap individual particles. Ultra-high vacuum systems create emptiness more complete than the space between galaxies. Detection systems capable of registering single, particle interactions operate with timing precision, measured in picoseconds. The medical applications of antimatter produced in these cosmic laboratories have already begun to save lives. Positron. Emission tomography PET scans use the annihilation radiation produced when positrons encounter electrons in human tissue to create detailed images of organ function and disease processes. In this application, antimatter becomes a tool for healing, transforming from a cosmic mystery into a practical benefit for human health and well-being. Antimatter propulsion. Research represents one of the most exciting potential applications of laboratory-produced antimatter. The complete conversion of matter and antimatter into energy through annihilation represents the most efficient energy source theoretically possible, offering the potential for spacecraft that could reach significant fractions of the speed of light. While the technological challenges remain immense, the fundamental physics has been demonstrated in these cosmic laboratories. The production facilities for antimatter continue to evolve and improve. With each new generation of particle accelerators and storage systems capable of producing larger quantities of antimatter with greater efficiency, projects like the proposed Future Circular Collider would create a particle accelerator with 4 times the circumference of the LHC, capable of producing antimatter in quantities and studying it with precision that would have been unimaginable just decades ago. As we drift through the control rooms where teams of scientists from dozens of countries collaborate to unlock antimatter secrets, we witness one of humanity's greatest cooperative endeavors. The quest to understand antimatter has brought together physicists, engineers, support staff from every continent, creating a global community united by curiosity about the deepest mysteries of existence and dedicated to pushing the boundaries of human knowledge. The data analysis systems that process information from antimatter experiments operate at scales that challenge the limits of computation. When particles collide at the LHC, they produce more data in a single second than humanity produced in the first several millennia of recorded history. Advanced artificial intelligence systems and distributed computing networks spanning the globe work continuously to sift through this cosmic information, searching for subtle signatures that reveal antimatter secrets. As we prepare to leave these laboratories of creation, let your mind rest on the profound realization that human beings have become cosmic alchemists, capable of transforming energy into the most exotic forms of matter and recreating conditions that existed only in the first moments after the Big Bang. In these temples of science, we have learned to speak the universe's fundamental language and to ask it direct questions about its deepest secrets. The antimatter created in these laboratories connects us directly to the cosmic war that shaped the early universe. Every antiproton trapped in a magnetic bottle, every positron annihilating in a detector, every antiatom formed from electromagnetic forces represents a continuation of the ancient drama that determined whether existence itself would be possible. Through these experiments, we are not just studying the universe, we are participating in its ongoing exploration of the balance between creation and annihilation. As you drift toward deeper relaxation, carried by the knowledge that human civilization has achieved the remarkable feat of creating and controlling antimatter, remember that you are part of a species bold enough to recreate the conditions present at the dawn of time. The same curiosity that drives you to ponder the mysteries of existence has led your fellow humans to build machines capable of manufacturing the cosmic twins and probing the secrets of the matter-antimatter war that made your very existence possible as we drift away from the earthbound laboratories where antimatter is born and tamed. Let your consciousness float gently toward the realm of dreams and possibilities, the future visions where antimatter might power humanity's greatest journey into the cosmic depths. Here in the space between what is and what might be, we explore the extraordinary potential of antimatter propulsion, the technology that could transform our species from planetary dwellers into true children of the stars, carried across the galaxy by engines powered by the same cosmic war that shaped the early universe. Picture yourself floating beside a spacecraft unlike any vessel ever conceived, its sleek hull containing the most powerful engines theoretically possible, antimatter. Rockets that harness the complete conversion of matter and antimatter into pure energy. Unlike chemical rockets that burn fuel and oxidizer to produce thrust, or nuclear rockets that split atoms to generate propulsion, these dream engines would annihilate matter and antimatter completely, transforming both participants in the cosmic dance into radiation, traveling at the speed of light. The physics of antimatter propulsion represents the ultimate expression of Einstein's famous equation, E equals mc, where the complete mass of both matter and antimatter fuel converts to energy with perfect efficiency. When a single gram of matter meets a single gram of antimatter, their mutual annihilation releases approximately 90 trillion joules of energy, equivalent to the explosion of 2,000 tons of TNT, or the electrical energy consumed by a major city in several hours, all contained in the marriage of cosmic twins, no heavier than a peplikla. As we float through the engineering dreams that surround antimatter propulsion, we encounter spacecraft capable of achieving velocities that would shrink the galaxy to manageable proportions. A properly designed antimatter rocket could accelerate continuously for months or years, eventually reaching significant fractions of the speed of light, velocities that would make the journey to nearby stars feasible within human lifetimes. Rather than requiring the millennia demanded by conventional propulsion systems, imagine drifting alongside a deep space vessel as its antimatter engines ignite for the first time. Their exhaust consisting of pure annihilation, radiation-focused, into a directed beam by magnetic nozzles that channel the energy of matter-antimatter destruction into controlled thrust. The specific impulse, the measure of rocket efficiency, would exceed that of any conceivable chemical or nuclear propulsion system by factors of hundreds or thousands, making interstellar travel not just possible but practical. The fuel tanks of these dream spacecraft would contain the most exotic cargo ever conceived, magnetic bottles holding antimatter in perfect isolation from the surrounding matter of the ship's structure. These cosmic fuel reservoirs would require magnetic field strengths and vacuum levels that exceed anything currently achievable, presenting engineering challenges that push the boundaries of what physics allows but do not violate any fundamental laws of nature. As we explore the technical dreams surrounding antimatter propulsion, we encounter systems that would make the spacecraft themselves the most complex machines ever built. The magnetic confinement systems would need to operate flawlessly for years or decades, maintaining perfect containment of the antimatter fuel while the spacecraft accelerates, coasts through interstellar space, and eventually decelerates at its destination. A single failure in these containment systems would result in the instant annihilation of the entire fuel supply. The energy management systems for antimatter spacecraft would dwarf the complexity of any power grid ever conceived. The controlled annihilation of matter and antimatter would produce more energy per second than many power plants generate. Yet this enormous energy release must be precisely controlled and channeled into useful thrust while preventing the spacecraft from being destroyed by its own propulsion system. Picture yourself floating in the crew compartments of these interstellar vessels, where human beings would experience journeys across distances so vast that communication with Earth would be delayed by years. The psychological and social challenges of interstellar travel would be as significant as the technical ones, requiring closed-loop life support systems capable of sustaining human communities across decades of flight time through the empty darkness. Between the stars, The navigation systems for antimatter-powered spacecraft would need to operate with precision, beyond anything currently conceivable, at velocities approaching significant fractions of the speed of light. Even tiny course corrections would require enormous energy expenditures, and the effects of special relativity would become significant factors in mission planning. Time dilation would mean that crew members would age more slowly than people remaining on Earth, creating temporal disconnections that would fundamentally alter the human experience of space exploration. As we drift through the mission profiles enabled by antimatter propulsion, we encounter journey possibilities that transform humanity's relationship with the cosmos. Robotic probes powered by antimatter engines could reach the nearest stars within decades rather than millennia, turning scientific data and images. That would revolutionize our understanding of planetary systems and the prevalence of life throughout the galaxy. The manufacturing requirements for antimatter fuel represent perhaps the greatest challenge in realizing these propulsion dreams. Current antimatter production capabilities would require millions of years to produce enough fuel for a single interstellar mission, demanding revolutionary advances in production efficiency and energy costs. The antimatter factories of the future would need to operate on industrial scales, transforming vast amounts of energy into the cosmic fuel that could power humanity's expansion into the galaxy. Magnetic plasma confinement systems, evolved from current fusion research, might provide the technology needed to contain antimatter fuel safely over extended periods. These systems would create invisible bottles of magnetic force strong enough to hold antimatter indefinitely, while light enough to be practical for spacecraft applications. The magnetic coils and power systems would represent the most advanced superconducting technology ever developed. The radiation shielding requirements for antimatter spacecraft would present unique challenges, since the annihilation process produces gamma rays and other high-energy radiation as byproducts. The crew compartments would need to be protected by sophisticated shielding systems that block deadly radiation while remaining light enough not to compromise the spacecraft's performance. These shields might incorporate magnetic deflection systems that push charged particles away from the crew areas. As we explore the payload capabilities of antimatter propulsion, we discover spacecraft that could carry substantial human populations and all the equipment needed to establish self-sustaining colonies around distant stars. Unlike conventional propulsion systems that can carry only tiny payloads across interstellar distances, antimatter rockets could transport entire communities, along with the industrial equipment needed to build new civilizations among alien suns. The scientific instruments carried by antimatter-powered exploration vessels would revolutionize our understanding of the galaxy and our place within it. High-resolution telescopes and sensors could study exoplanets in unprecedented detail, searching for signs of life and characterizing the atmospheric and surface conditions of worlds orbiting other stars. The data returned by these missions would fundamentally alter humanity's perspective on the prevalence and nature of life throughout the cosmos. Interstellar communication systems would need to evolve to support antimatter-powered exploration missions. The vast distances and long travel times would require new approaches to maintaining contact between Earth and interstellar expeditions. Powerful laser communication systems might create information highways across the galaxy, allowing human civilization to remain connected. Even as it spreads among the stars, the economic implications of practical antimatter propulsion would transform human civilization in ways that are difficult to imagine. Access to the resources of entire star systems would make material scarcity obsolete, while the energy requirements for antimatter production would drive advances in fusion power and other energy technologies that would benefit all aspects of human society. Imagine the universe as a silent stage, draped in darkness. The curtain of night falls, stars flicker like faint lamps, and behind their quiet light lies a secret so vast it unsettles even the calmest dreamer. Something happened at the dawn of time, something strange, something that should not have left us here at all. For if the laws of symmetry had their way, if balance were perfect and fair, then matter and antimatter, those eternal twins, would have embraced each other in annihilation, vanishing into pure light. The cosmos would be empty, nothing more than a smooth sea of radiation. No galaxies, no planets, no atoms, no you, no me, and yet here we are. A mystery, a cosmic crime scene. And so begins the detective story of physics, the greatest investigation ever undertaken. The detective enters the room. The room in this case is the universe itself. He shines a dim lantern across the cosmic expanse, and what does he see? Matter everywhere. The stars, the dust, the breath inside our lungs. But if the rules of creation were followed strictly, he realizes this should not be so. For every proton that appeared in the fireball of the Big Bang, an antiproton should have been born beside it. For every electron, a positron. Perfect twins, bound to destroy each other. The detective whispers to himself, where did the antimatter go? It is a quiet but haunting question, like a single violin playing in an empty hall. Because to ask it is to face the unsettling thought that the universe we know is only half a truth, a lopsided survival story. Somewhere in the early seconds after time began, a coin was tossed, and it landed on matter's side. Why? The detective story begins. Our detective is not a single person, but a chorus of human minds across the ages. Some carry chalk, some carry telescopes. Others carry equations like lanterns into the dark. In 1928, a young theorist named Paul Dirac sat at his desk, searching for an equation to describe the electron. His chalk slid across the blackboard, weaving symbols that hummed with elegance. The equation worked, sang with the music of relativity and quantum mechanics combined. But hidden within its structure was a ghostly whisper, a prediction of something strange. Dirac's equation suggested that for every electron, there must exist another particle. Same mass, opposite charge, twin, but inverted. At first, he called it a negative energy state, mathematical oddity and artifact of the equation, but the whisper grew louder. The detective in Dirac could not ignore the clue. He realized his math was pointing towards something real, the positron, the electron's antimatter mirror. He had not seen it. He had not touched it. But like a detective finding footprints in the snow, he knew something, or someone had, passed this way. 4 years later, in 1932, a young physicist named Carl Anderson was scanning photographs of cosmic rays in his cloud chamber. These rays were the high-energy fingerprints of particles colliding in the upper atmosphere. Tiny tracks etched in mist, each one a clue from beyond Earth. Anderson saw something peculiar. A track that curved as though it belonged to an electron, yet the curve bent the wrong way in the magnetic field. It was as if the particle were a reflection in glass. He had found the suspect, the positron, the antimatter twin predicted by Dirac. Imagine the detective's excitement. The case was no longer abstract. Antimatter was real. Left tracks, curved trails in mist, the delicate handwriting of the invisible world. The universe, it seemed, contained doubles of everything. Protons with antiprotons, neutrons with antineutrons. A mere kingdom lurking beneath the surface, but as every detective knows, the appearance of a suspect only deepens the mystery. If matter and antimatter exist in equal measure, then why is the cosmos filled with one and not the other? The detective turns over the clues. He studies collisions in particle accelerators, where matter and antimatter can be made to dance. He watches them annihilate in perfect flashes of light. Symmetry seems flawless, balanced, fair, and yet the stars overhead whisper of imbalance. The galaxies are not made of antimatter. Cosmic rays, those messengers from space, do not strike us with equal parts matter and antimatter. Entire regions of the universe glow with the light of matter alone. Somewhere, in the first moments of creation, symmetry was broken. The detective circles the word in his notebook. Asymmetry. This is the central clue.
And the twist in the tail.
Next lead arrives in the mid-20th century. Physicists study the decays of subatomic particles known as kaons. These strange little entities, born fleetingly in high-energy collisions, behave in ways that seem almost mischievous. When their decays are observed, matter and antimatter do not act as perfect mirror images. a tiny difference creeps in, a subtle bias. This phenomenon is called CP violation, the breaking of charge parity symmetry. It is as though the universe, when questioned under the bright lamp of interrogation, reveals a hidden preference. Slight tilt toward matter, the detective smiles, weary but intrigued. This is no smoking gun, no grand confession, but it is something. A smudge on the fingerprint, a clue that perhaps long ago the laws of physics leaned ever so slightly in favor of matter, allowing it to survive. But how slight? And is it enough to explain why galaxies form? Why you and I exist? The detective shakes his head. The case remains open. When earthly clues are too faint, detectives turn to witnesses. And in this cosmic mystery, the witness is the universe itself. The cosmic microwave background hums softly across the sky. The afterglow of the Big Bang, it carries within its delicate ripples a record of matter's victory. It tells us that in the first split second of time, for every billion pairs of particles and antiparticles, there was just one lonely matter particle left unannihilated, 1 in a billion, a tiny surplus, yet enough to build everything we see. The witness has spoken. Matter won by the slimmest of margins. But the witness does not explain how. It only describes the aftermath, not the cause. The detective listens carefully, pen poised, but the universe gives no further testimony. It's just a long, steady hum, a lullaby of light from the beginning of time. And so we return to the room of the universe, lantern dimming. The detective sets down his notebook, pages filled with names, dates, equations, collisions, Dirac, Anderson, CP violation, cosmic background radiation. The mystery is not solved. Not fully. We know antimatter exists. We know it behaves as a twin to matter. We know that in principle, the universe should have contained equal amounts of both. Yet here we are, in a world of matter, with antimatter reduced to a whisper, a rarity glimpsed only in experiments and cosmic rays. Why did matter win? What hidden law tilted the balance? Was it chance? A fluctuation at the beginning? Is there a deeper symmetry, one we have not yet uncovered, waiting to be brought to light by future detectives of the cosmos? The file remains open. The universe, it seems, guards its secrets well. And so, as you drift towards sleep, imagine the universe as a vast detective novel still being written. We are both readers and investigators, turning pages of starlight, following footprints in particle tracks, listening to the whispered testimony of ancient photons. Perhaps, far away in the hidden folds of space-time, antimatter still lingers, an unseen twin world, inverted and luminous, waiting for us to discover it. Or perhaps the answer is already here, woven into the smallest asymmetry, the gentlest tilt of nature's laws. For now, the mystery rests beside you like an unopened book, its pages glowing softly in the dark. Close your eyes and let the story cradle you, the detective, the suspects, the silent witnesses, the unsolved case. A cosmic lullaby. A mystery that dreams on even as you do. The investigation continues. The detective closes his notebook for the night. The case unsolved glows faintly in the lamplight, yet as he leans back in his chair, he realizes something profound. The mystery is not buried in the past, not locked away in the first seconds of the universe. No, it continues still. The struggle between matter and antimatter is not a story that ended. It is ongoing, stitched into the very fabric of existence. Everywhere he looks, the battle continues. In stars, in cosmic rays, in the quiet hum of laboratories, beneath the earth, in theories scribbled on chalkboards where symbols wrestle like combatants in silence. This is no ordinary war. There are no banners, no swords, no cries. It is a war of particles, silent flashes of annihilation, faint whispers of symmetry broken. It is the eternal war that shaped us, that sustains us, that refuses to rest. And so the detective takes up his lantern again. Not to close the case, but to follow its echo into the stars, into the accelerators, into the uncharted pages of Tomorrow, close your eyes and drift into the heart of a star. There, inside its blazing furnace, the battle rages on. Protons crash together at unimaginable speeds, and in the collisions, fleeting shadows of antimatter are born. Positrons appear like sparks, antiprotons flicker into existence, only to vanish almost instantly in the embrace of their matter twins. The war is endless, but it is not balanced. Matter holds the advantage. Every annihilation is but a skirmish, a reminder of the great imbalance set at the dawn of time. Yet antimatter has not vanished completely. It lingers, appearing in bursts, fighting its quiet duels, keeping alive the memory of a war once fought at cosmic scale. To the detective, the universe now feels like a battlefield frozen mid-motion. The armies are unequal, the struggle uneven. Yet the war continues in every corner of reality, hidden in the ordinary, carried in the extraordinary. The stars themselves are battlegrounds. Nuclear reactions inside them do not simply forge light and heat, they birth shadows. For in the alchemy of fusion, antimatter particles are created as byproducts, appearing like rival knights summoned to the field. A proton and neutron join, forging deuterium, and in the process, a positron is cast into existence. That positron does not live long. Almost instantly, it finds an electron, and together, they vanish in a burst of gamma light. This cycle repeats endlessly, woven into the heartbeat of stars. In every ray of starlight that touches your skin, there is the echo of a war. A positron born, a positron destroyed. Annihilation and creation entwined, light blossoming from the kiss of matter and antimatter. It is a war we owe our lives to. Without those fleeting annihilations, stars would not shine as they do. Without the light of stars, there would be no warmth for planets, no chemistry for oceans, no spark of life. The eternal battle is not only destruction, it is creation disguised, beyond. The stars, another theater of war, stretches across the sky. Cosmic rays, high-energy messengers from distant galaxies race through the universe like wandering soldiers. Some are matter, some are antimatter. They collide with Earth's atmosphere, striking air molecules, leaving showers of particles behind. When detectors catch them, we see both matter and antimatter fingerprints. Positrons again, antiprotons, sometimes born from these violent cosmic duels. They are rare, precious, but they remind us that the war is not confined to the past or hidden in stars. It is written into the rain of energy that still falls on our planet from the heavens. The detective gazes upward at night and wonders, what distant battlefield sent this soldier here? What ancient clash between galaxies? What explosion of stars? What invisible duel gave birth to this antimatter particle that traveled millions of years only to dissolve in our atmosphere? The sky becomes a war report, written not in words but in radiation. But perhaps the most deliberate battlefield is the one we built ourselves. In vast underground rings, miles long, we recreate the conditions of the early universe. Particle accelerators like the Large Hadron Collider are not only laboratories, but arenas where matter and antimatter are summoned, forced to face one another. Here, protons whirl at near-light speeds, crashing together in sparks of unimaginable energy. Out of the collisions, particles bloom, quarks, leptons, bosons, and their shadow twins of antimatter. It is a man-made reenactment of the primordial battle carried out with detectors instead of shields, with data instead of scars. Physicists are both generals and detectives here. They command the collisions, but they watch with patience, measuring every particle that emerges, seeking signs of imbalance. For in the way antimatter behaves, in the way it decays, there may be hidden asymmetries, the fingerprints of the war's beginning. Every time two beams collide, it is as if we are interrogating the universe itself, asking it to confess why it chose matter over antimatter. In the quiet of night, the detective pores over the writings of theorists. Their words are not stories but equations, symbols dancing across chalkboards, rules that might govern the eternal battle. They speak of baryogenesis, the hypothetical process that tipped the scales in favor of matter. They recall Sakharov's conditions, 3 rules that must be met for matter to triumph: violation of baryon number, violation of symmetry, and departure from thermal equilibrium. Conditions that may have been met in the seething chaos of the Big Bang. It is as if the war had laws written not by men, but by the universe itself. Laws that determined who would win and who would fade, but as with any war, the truth is hazy. Histories are incomplete, the records smudged by time. Cannot yet prove how the balance tipped, only that it did. And so, the detective reads on, scribbling notes, chasing shadows. Then comes the strangest question of all. Could the war have split the universe, leaving pockets of antimatter untouched, galaxies that glow with their own mirrored light? Physicists have searched. They look for the telltale gamma rays that would appear if matter and antimatter galaxies collided at their edges. They have not found them. The silence of the cosmos suggests matter reigns alone, and yet the thought lingers. Perhaps beyond the horizon we can see. Entire clusters of antimatter stars exist, their light indistinguishable to us, their chemistry a mirror of ours. Perhaps somewhere there are beings of antimatter looking up at their night sky, wondering the same about us. It is speculation, a dream, but in the lull of midnight thought, the detective allows himself to imagine it, a rival world unseen, untouched, waiting. Every war leaves scars. In this war, the scar is annihilation. Matter and antimatter, when they meet, do not simply vanish. They release energy. Pure light. It is a wound that glows, a destruction that creates. In laboratories, we harness this principle. Positron emission tomography, PET scans use antimatter annihilation to peer inside the human body, turning the war's weapons into tools of healing. Scientists dream of using antimatter as fuel, for it contains unimaginable energy, a starship's dream, sun held in the palm of a hand. The detective marvels at this paradox, that annihilation, the war's act of ultimate destruction, becomes a source of knowledge, of healing, potential creation. Perhaps this is the war's deepest lesson, that endings can shine, that erasure can illuminate, that even destruction hums with beauty. As dawn approaches, the detective sets down his lantern. He knows the war will not end tonight. It may never end. It is eternal, woven into the laws of physics, sustained in stars and accelerators. In theories and dreams, matter may have won the first great battle, but the mystery remains unsolved. The eternal war continues in the silence of galaxies, in the equations of theorists, in the hum of particle beams beneath the earth. We are its children, born of matter's victory, survivors of annihilation's storm. And yet in every starbeam, in every cosmic ray, in every burst of light from annihilation, we are reminded that the other half of creation is still out there. Still fighting, still whispering its name. The detective closes his notebook one final time. The case is unsolved, but perhaps that is its beauty. For in mysteries that endure, we find stories that never end. And so, as you drift into sleep, imagine yourself a witness to the eternal battle. Above you, stars blaze not just as lanterns in the dark, but as theaters of annihilation and creation. Within you, atoms whisper of survival, of being the lucky few who escaped the storm of annihilation at the dawn of time. The war is not violent in the way of men. It is quiet, eternal, woven into light itself. It does not wake you, it lulls you, for in its endlessness there is comfort. The universe has fought its greatest war, and still it cradles you gently within its arms. Close your eyes and feel it. The eternal war continues, not as noise, but as a lullaby. It's not as terror, but as wonder. Sleep now, child of matter. You are the survivor of a cosmic war, and the stars, eternal witnesses, sing you to rest. The detective stands at the edge of tomorrow, lantern dim in his hand, the cosmos stretching before him like an unopened book. Behind him lie the mysteries of the past, Dirac's chalkboard whispers, Anderson's curved particle tracks, the endless duels within stars, the silent clues and cosmic rays. But ahead, the path is not yet written. The case file is still open. The eternal war between matter and antimatter is not finished. and its future is as wide as the universe itself. The detective does not close his eyes. Instead, he looks forward. He asks, "What comes next?" And so begins the final chapter of our lullaby. The story of a war that may shape not only our understanding of the cosmos, but our very future. If the past was discovery, the future is pursuit. We stand at the threshold of new experiments, new questions, new instruments of cosmic interrogation in underground caverns, shielded from Earth's noise. Detectors are being built to listen for whispers of antimatter. In vast rings of superconducting magnets, scientists prepare to collide particles with energies higher than ever before. Searching for patterns in the wreckage, the detective sees them as watchtowers on the frontier, instruments of listening, and light their data streams like the murmurs of witnesses still waiting to be heard. And beyond Earth, telescopes orbit silently, their mirrors tuned to capture cosmic rays, gamma flashes, the possible signatures of distant antimatter worlds. The battlefields of the future are not in blood and soil, but in equations and light, in particles and probabilities. At CERN, a team of physicists gathers around a device called Alpha. Their goal is to trap antimatter, to hold it, study it, question it like a delicate suspect. They succeed in catching atoms of antihydrogen, holding them in magnetic cages for fractions of a second, then seconds, then minutes. In those fragile prisons, scientists ask, does antimatter fall the same way matter does? Does it obey gravity's pull, or does it rise instead, defying the symmetry we expect? The detective smiles at this strange thought, dropping an atom of antimatter to see if it falls. It is such a simple question, yet so profound. For the answer could reveal cracks in the laws we thought unshakable. In another lab, positrons and electrons are brought together in controlled annihilation, their gamma light measured with exquisite precision. Elsewhere, accelerators smash heavy ions, hoping to glimpse conditions like those in the first moments of the Big Bang, where the Great War was decided. Each experiment is a conversation with the cosmos, a gentle interrogation of the laws that chose matter over antimatter. Theorists to continue their vigil. Their chalkboards fill with fresh attempts to solve the imbalance, supersymmetry, hidden dimensions, new particles not yet seen. They wonder, is there a force we do not know, bias written deeper into the fabric of the universe that caused matter to survive? Could dark matter, that mysterious substance outweighing all the stars we see, be linked to the disappearance of antimatter? Could the war be more complicated than we imagine, involving players not yet revealed? The detective considers this. In every great mystery, there are suspects not yet questioned, clues not yet uncovered. The story of antimatter may be tied to shadows darker still, mysteries not even named, and so the future may hold surprises. The war may have twists left untold, but the war is not only about survival, it may one day shape our destiny. For the very annihilation that once threatened all creation may become a tool of creation itself. Consider energy. When matter and antimatter meet, their annihilation releases pure light, pure energy. Fuel is more efficient, no engine more powerful. A single gram of antimatter could unleash energy equal to the largest bombs humanity has ever made. But, focused, directed, it could power ships, cities, dreams. The detective imagines a starship, sails of light unfurling, engines burning not with chemical fire but with the annihilation of matter and antimatter. Across the void, generations would travel, carrying life into the deep. Already, in hospitals, we glimpse this possibility. PET scans, using positrons, turn annihilation into a healing light. In research, tiny quantities of antimatter are created, studied, held, though fragile, though costly. It is a beginning. Perhaps one day, what was once an enemy will become our greatest ally. But even as we dream of harnessing antimatter, the detective wonders, where is it now? Could entire galaxies of antimatter still exist, hidden beyond our gaze? The silence of the skies suggests no. If matter and antimatter galaxies touched, their borders would glow with annihilation, painting the cosmos with gamma rays. Yet we do not see this. Still, the search continues. Space probes, detectors on the International Space Station. Instruments like the Alpha Magnetic Spectrometer scan for heavy antimatter nuclei drifting through space. A single confirmed anti-helium nucleus would hint at something extraordinary. That far away, there are stars not made of matter, but of antimatter, blazing in inverted brilliance. The thought is dizzying, dreamlike. Perhaps the war is not finished, but divided, each side holding a distant territory. Across cosmic gulfs, the rivals remain, never touching, never seen. The detective leaves the question open, as if writing to be continued at the bottom of his notebook. What does it mean to be children of matter's victory? To be the survivors of a cosmic annihilation that erased nearly all, leaving only one particle in a billion to seed galaxies, stars, and life. Means we are improbable, miraculous. The descendants of an ancient imbalance, born from a war that should have left nothing at all. The detective pauses here, humbled. For in the soft weight of our existence, in the quiet beating of a human heart, lies the story of the greatest battle ever fought. Not by armies, not by kings, but by the universe itself. To know this is to carry a kind of gratitude. You're here because matter won. And yet, we are haunted by the knowledge that antimatter still lingers, still resists, still reminds us that the war is eternal. And so the detective looks outward. What will we find in the next century? Will we uncover the true reason matter triumphed? Will we discover new particles, new laws, new clues that finally close the case? Or will the mystery remain unsolved, stretching across generations? As eternal as the war itself, the future holds no promises, only questions, only possibilities. But in those possibilities lies wonder. For the search itself is a kind of lullaby, soothing us with its endlessness, reminding us that the universe will always have secrets left to tell. And now, as night deepens, the detective dims his lantern. He sets aside his notes, not with frustration, but with peace. The war continues, but it does not need resolution tonight. It may never need resolution at all, for the story is not only in the answer, but in the search. In the questions whispered by stars, in the clues traced by cosmic rays, in the laboratories humming quietly beneath our feet, the eternal war between matter and antimatter is not an end. It is a song still being sung, a melody that carries us into the future. Close your eyes and listen. Hear the soft hum of annihilation turning into light. Hear the patient footsteps of scientists as they follow the trail. Hear the silence of the universe, vast and unsolved, cradling you gently. The war will continue. The story will go on. But for now, you may rest. Sleep, child of matter. The cosmos watches over you. The case remains open, and so, dear dreamer, the story of matter and antimatter, this secret war of twins, comes to a resting place in our tale, though never in the universe itself. The battle still drifts silently among the stars, unfolding. In realms too small for eyes, too vast for imaginations, too delicate for noise. Yet here, in the quiet of night, we can lean close, as if pressing an ear to the chest of the cosmos, and listen to its slow, patient heartbeat. For what is this story if not a lullaby of survival? Its matter, fragile and improbable, somehow outlasted its mirror. Antimatter, like a shadow partner, vanished into sparks of light. But the memory of that primordial struggle still echoes in every atom that builds you, in every breath you take, in the gentle warmth of your skin beneath the covers. Without that ancient imbalance, there would be no earth, no sky, no you. Without that ancient imbalance, there would be no earth, no sky, no you. Close your eyes and picture it once more. A newborn universe, glowing with equal twins, particles and antiparticles, dancing like mirrored fireflies in a boundless meadow. Each time they met, they vanished into pure light. And yet somehow one twin stumbled, one slipped, one lingered. A seed of matter remained. From that tiny seed, galaxies bloomed like dandelions in a spring wind. From that seed, time itself learned to write its story. From that seed, you were born. Isn't it strange? That everything you've ever loved, every voice you've ever heard, every dream you've ever chased, depends on a fraction of a fraction, a whisper of imbalance. Had the universe been perfectly fair, perfectly balanced, then fairness itself would have left nothing behind, only light, stretching forever, with no one left to see it. Imperfection, it seems, is the reason we exist. And so, when you feel small, when the day has left you weary, and worries feel heavy, remember that you are here because of a cosmic accident, a delicate tilt in the scales of eternity. You are the survivor of an ancient war, carried forward not by might, but by chance, by a softness hidden deep in the rules of reality. Your very breath is victory. Perhaps then, matter and antimatter are not enemies at all, but partners in a dance too. Mysterious for us to fully grasp. They collided, they vanished, they gave their light. Their war was not destruction, but creation. For in the glow of their ending, the universe found a beginning. As you drift now into sleep, imagine the stars above as embers of that first fire, still burning, still whispering. They keep the memory of that battle alive, not as sorrow, but as song. They remind us that life is born from contrast, light and dark, sound and silence, matter and antimatter, wakefulness and sleep. And now it is your turn to surrender to that rhythm, to let go, to rest. For even the universe rests, in its own way, expanding softly, breathing in silence, waiting for tomorrow. Tonight, let your mind become a galaxy. Let your thoughts be drifting stars. Let your worries dissolve like antimatter, meeting matter burning away into nothing but gentle light. Feel the quiet symmetry of your heartbeat, the tender pull of gravity that keeps you grounded, the hush of time as it slows in your room. Somewhere deep in the fabric of space, the story continues. New experiments will be run, new mysteries revealed. Scientists will keep listening, keep asking, keep searching for the missing clues of antimatter. But you need only rest. The universe is vast enough to hold its questions until morning. So, sleep now, traveler of thoughts. Sleep as if the cosmos itself is tucking you in, wrapping you in starlight and silence. Sleep as if every atom in your body is humming a lullaby written 13.8 billion years ago. Sleep, and know that you are part of the story that the universe itself dreamed you into being. That in your dreams tonight you may wander among the galaxies that were born from war yet live in peace. The war between matter and antimatter may never truly end. But here in this moment, there is no need for battles, no need for questions, no need for answers. There is only stillness. There is only rest. There is only you, floating gently in the cradle of the stars. And as your breathing slows, as your thoughts dim like candles, remember this. The universe is watching over you, always. It has carried you from its first spark to this very night. And it will carry you still, into tomorrow, into dreams, into the endless lullaby of time. Good night. Dear listener, good night, dear star.